Today, this panel is Seeing is Believing, Building Smart Cities with Advanced Data Visualization. The idea or the dream of an advanced smart city is really hard for people to realize. And it's critical that different stakeholders come to a consensus on infrastructure investments and other investments as we move forward and try to realize this smart cities dream. So today we're going to talk about how technology can really impact that view and long-term plan of a smart city. So with me to talk about this today, on my left over here we have Damali Rhett. Damali is the Executive Director of the Energy Co-op. Hi Damali, how are you?
I'm good, how are you?
I'm doing pretty well. And then next to her we have Matt Fudge. He's the Strategy and Business Development Lead for NREL. Hi Matt, how are you?
Hi there, nice to see you.
And then next to me is Mike Hess. Mike is the Vice President of Smart and Sustainable Buildings for Panasonic Enterprise Solutions. How are you?
Fantastic.
All right, so that was just a quick intro. I'm going to go ahead and let these panelists give a little more in-depth intro about themselves and why they're here to be part of this conversation. So Damali, if you want to go ahead and start with that.
So good afternoon, everyone. I am Damali Rhett. I am Executive Director of the Energy Co-op, which is a Philadelphia-based retail energy co-op. And so as far as I can find, we are one of about a dozen retail-only co-ops that do energy in the United States, which makes us a little bit different. And so we offer renewable electricity. We also offer heating oil to our members, as well as we actually created and innovated a renewable natural gas credit program that we offer to our members as well. So why I am really excited to be on this panel is because I consider kind of this co-op model to be transformative in the energy space. And so on the last panel I attended, one of the panelists talked about CCAs. We're a great alternative to CCAs, right? So as a co-op, we can make decisions. Again, like this morning, I was actually looking at our patent on a renewable natural gas credit, but you can't really do that easily if you are a large corporation or if you are a municipality, because you're really not primed to kind of take advantage of some of the spaces like we can do with very little red tape. And so I'm excited to be here and talk a little bit more about what the city of Philadelphia is doing in particular around using kind of data visualization and how that kind of interacts with us as a cooperative, but also with us as a community-based organization.
Fantastic. And my name is Matt Fudge. I run the strategy and business development for the National Renewable Energy Laboratory. If you guys are not familiar with it, it is a federal facility. It's primarily funded by the Department of Energy, but we do a tremendous amount of partnerships. Just a quick rundown of numbers for you. The lab is about a $400 million per year facility. About roughly $60 to $75 million of that $400 million is work that we do with companies that you've seen here today already, Duke Energy. We do a lot of work with utilities in California, New York, all over the world. We also do a lot of work with technology companies like Panasonic, Boeing. We do work all over different verticals, industry verticals. But what I'm here today to talk about with my companions here on the panel is about one particular technology that we're working on of many, which is essentially the ability for many stakeholders to look at the same complex data and infrastructure at the same time, which is something that's very difficult in our industry, I think. So that's why I'm excited to be here.
I'm Mike with Panasonic. I am part of our Smart City team. I lead a lot of our upfront sustainability, energy, technology planning for developers, cities, and utilities. A lot of my friends think I sell televisions and cameras because I work at Panasonic, but they don't realize that we created a kind of a product agnostic smart city solutions team a couple of years ago that does upfront energy planning and turnkey solutions. And I'm here because I'm actually Matt's guinea pig. A lot of the visualization that you're going to see comes from one of our projects where, as we started our smart city team, we sort of had to put our money where our mouth is and decided to actually invest equity and build a smart city project. And part of that is the energy planning and visualization that NREL is helping us with.
Thank you. So we're going to do something a little different. We're actually going to start this panel off with a short video.
Hi, I'm Matt Fudge from the National Renewable Energy Laboratory. I run the strategy and business development for the Energy Systems Integration Facility. What you see back here is a very interesting and complex piece of data. It's three-dimensional and allows investors and other people like utilities and vendors to think about things like power systems, net zero design, any type of complex energy system. You see something that represents 400 acres of flat prairie land near the Denver International Airport. And the goal of the project is to do what's called a net zero energy development. Now, you as the audience here at the Energy Thought Summit know exactly what I'm talking about. Ultimately, the outcome of this project will be a filing or some type of mechanism that allows the State Commission and the utility and all the other stakeholders make a decision or a series of decisions about how we're actually going to achieve net zero and a very close to 100% renewable energy design. How can that be done without breaking the bank or breaking the grid? So the one way to do that is to visualize the data.
We understand the world by walking through the world, by interacting with the world. And that's what we're trying to bring to computational data through our immersive virtual environment, is the ability to walk through the data, to immerse ourselves in those computational data. By tracking the user's head position with the glasses, it allows us to physically walk through the data in the same way that we physically walk through the world. So we're capitalizing on all this learned and evolved ability, in our cognitive processing that allow us to kind of see these anomalies and patterns in the data, but see them in an embodied way.
So the real challenge here is, how do you design a net zero energy district so that everybody wins? The developer, the utility, and the community at large, the customers ultimately. So the visualization really brings this to life for the different stakeholders. It's one thing to sit in a room and look at a blueprint of a feeder topology and say, okay, we're going to put some solar here. What this allows us to do is show the utility and show the developers the impact that it's going to have on the system, and easily make changes and then show how those changes translate through the system. So for example, if you put more solar PV panels here, what does that do to your net zero energy impact? But then also, what does that do to the power system in that location as well?
So it's important to note that this project is only feasible because it's a collaboration. So all of our input data comes from our collaborators, starting with the developer of the district. So within the simulation, each of these 100 buildings is based on developer data and simulated with a building systems model before it gets put into our power systems model.
It doesn't matter what industry we're talking about, we're trying to shorten the time span that is required to make multi-billion-dollar decisions, risky decisions for really complicated technological industries.
Awesome, thank you, Matt. So, Mike, you mentioned in your intro that you are Matt's guinea pig. So, kind of talk to us about what we just saw in the video and how you are involved with what Matt's team is doing at NREL.
Okay, I'll actually start by just giving a little background on the 400-acre project that Matt actually talked about in the video. So that development is called Peña Station Next. It's in Denver, very near to the airport. As was said, it's a 400-acre project. There's really not a whole lot there yet. There's a train station, our office building is there, but it is more than just a typical development. It's actually a living lab for smart cities in partnership between Xcel Energy, our utility, Panasonic, City of Denver, and a few other folks. So we are actively testing all kinds of technologies there, from autonomous vehicles to side-by-side tests of multiple vendors for smart streetlights, smart building applications. So it's a great test ground where all of our partners can sort of test things out and then figure out how to roll them out to the greater city or out to the greater to the rest of the country. So it's a pretty cool living lab. From an energy perspective, we've already made a lot of deployments in that the initial phase, we've actually built a utility scale microgrid in partnership with Xcel that is already in place, roughly 2 megawatts of solar power and a 2 megawatt hour battery. The 2 megawatt hour battery is actually a utility owned battery, and Xcel is using it for grid services and testing it for other applications. It also serves as our backup power source. So our building automation system actually communicates with Xcel's controls for the microgrid. If the normal utility power goes down, we actually talk with the battery check battery charge state, do demand response in our building, and load shed to make sure that our network operations center stays online. So it's already sort of an interesting test case that we built, but it wasn't enough. We've got almost 400 more acres that is getting master planned out right now. And we really wanted to sort of test the boundaries and figure out, as both an owner and a solutions provider, how can we try to achieve carbon neutral net zero energy for a development in a way that hasn't really been done. So we reached out to NREL as a potential new partner with Panasonic and Xcel and others on how can we plan out the rest of this neighborhood. So, the visualization that you saw looks really cool. To me, the most important part, sort of from a developer solutions provider perspective, is how NREL has linked all of our building energy models with Xcel's distribution modeling. So when we implement guidelines in our development to trim energy consumption by 1% or 2% with different technologies, real time we can see how that impacts Xcel's utility infrastructure. And because we're partners with Xcel, we look at those things together. So there may be building energy efficiency measures that, as a developer, we wouldn't just do on our own. But if it helps Xcel avoid feeder upgrades, substation upgrades, and allows them to then use that to partner in other ways to make this a carbon neutral neighborhood, that's really our goal. So Matt, I don't know if you want to sort of build on that with your.
And I'm going to hand off to Damali in a second, because I think what, if you don't mind, you guys are going to be surprised to hear me say this, because I'm actually not going to talk about the technology, because I think it kind of speaks for itself as to what we're trying to do in terms of matching energy load and getting physical infrastructure and seeing what the scenarios are and whether it's cost causation can work. But I actually want to talk a little bit about social equity and about whether or not really large projects that we all sort of, as an industry, have talked about for a long time, which is, can you do a very large city development at close to net zero? Is that actually possible? And I'm not talking about a smaller 2 or 3 megawatt kind of microgrid configuration, things that we've been talking about for decades, really, or military bases. I'm talking about something very large and scalable that people can afford. That the commission is willing, in this case, of investor-owned utility, that maybe they're willing to get cost neutral across the rate classes. Something that people who live in a very large development like that might actually be able to feel attracted to, that they can get land developers to be able to build those properties. That model between all these different stakeholders would actually work. So what I think is interesting about this particular project, it's not about the project or the technology. It's about asking this really fundamental question about, is this actually a business model that can work, that has some social equity into it, so that it's not just a really fancy, interesting, very expensive, 10 times cost thing. Can you actually get these technologies to work together to allow for a big development like that? And this is just one tool to allow everybody to see the information at the same time. It's real data. It's not all simulated. So anyway, I want to hand off to you, because I think you might have something to say about that.
So one of the things that's, I think, unique to Philadelphia is we have an Office of Sustainability, which is pretty typical in a municipality, but we also have what we call the Philadelphia Energy Authority, which is this quasi-government, it's actually state-funded but city-mandated government organization that is specifically looking at energy use as a means for kind of social and economic justice. And so all of these offices kind of work together in terms of thinking about, so if you take the City of Philadelphia, the Office of Sustainability, they do a lot of benchmarking studies. So if you actually have your phone, I will give you the website. So it's phillybuildingbenchmarking.com. I'll make sure that's right. It's a very fancy name. But one of the things that they have done, and they started off in 2013, and they actually say that they are the first city to do this, although there's a little bit of a kind of not sure there, but is start to kind of collect the data on energy use from initially it started with buildings that were over 50,000 square feet. So your typical warehouse, larger stores, things that you would have in the city. It started collecting that through an EPA kind of general form, but really converting that to visualization. So not just kind of regurgitating back to building owners, here are your stats, but one of the things they started doing, and what you'll see on that website, is actually mapping it and heat mapping it across a number of different dynamics, so that building owners, you may own 1 or 2 warehouses, right? So if you're a building owner, you own 1 or 2 warehouses. Energy cost is obviously a huge portion of your O&M expense, but you have no idea if the guy across the street is paying more or paying less or doing better, and you don't really want to go over and ask him, right? So now you actually have this independent organization that you can actually look on a neighborhood basis. You can look at an individual building basis and see, how do I compare to my neighbor? And by the way, I'm not an energy expert, and I can't afford to hire an energy auditing firm. So now how do I manage that if I think that now I can see that I'm actually doing better than him? So maybe I should just continue what I'm doing, or maybe I see that now I'm doing worse. So what are the things I can do? Do I call my local utility company up and ask them for ideas? Or do I go to a nonprofit? Or do I go to the Philadelphia Energy Authority and ask them for ideas and ask them to help come and maybe do an audit, or maybe look at, do I install solar or install something else? And so I think that's one of the ways, and kind of thinking about this idea of how do we actually apply data. And it's great to have this, but what does that actually mean for kind of your normal citizen or your small business, in terms of, I'm a community-based organization, so for me, it's always going to come back to the community. And I think taking something like this, where you could visualize and walk through it, if I'm a community member, like I got really excited about that about the VR this morning, because if I own multiple apartment buildings, now I can actually look and see, what does that mean from an energy use perspective? What might happen if I do have the ability to install solar, right? What does that look like? What does that mean from an experience of what I'm providing to the people who are renting from me, right? Do I create a better experience, or do I create something that maybe I realize that I'm going to block a view that I'm, getting a rent premium on? And so those are all of the kind of ways that we kind of come together to use the data and a means to kind of support this idea of social justice.
So it sounds like, Damali, you're really getting into the next part of the conversation, which I wanted to talk about. So Matt, I'll let you try to address this question first. Can you talk about, how this technology really brings value to organizations? Some people may say, this is cool, it looks cool, it's innovative, but it actually does bring different types of value. Can you talk to that a little bit?
Yeah, so we'll just take this particular project. So, and I want to speak for Mike's organization. I think for them it has a lot to do with, there's a lot of angles. I'll let you speak on that. There's a lot of things that I could say about what you guys can get out of it. I think for the other parties involved in this particular project, from a political standpoint, which is kind of where my background is before I came to the lab, it's difficult for a regulator of the commission to automatically get into an adversarial rate case that says, okay, you want to build let's say this project goes forward. You want to build a 400-acre, which is a lot of land, say 50 megawatt, let's just say that's what the load is, utility-owned, distributed, oriented, decentralized, net zero development, which is pretty big scale, right? And you want to spend $300 million, I'm just making up a number, $300 million of ratepayer money on that, and you want it to be cost neutral to everyone else. So from the regulatory standpoint, thinking about this, if I looked at that filing, I would have, as consumer advocates, as ratepayers, as the city, as big commercial industrial interest, even Panasonic, being a user, consumer of energy, it would be really difficult, I think, to make what I think is a equitable decision about that at the commission if you didn't have something a lot better than what our existing sort of paper-oriented, going through filings, looking at different kind of econometric analysis. It's a little bit better if you can get real power flow modeling in real time and actually see something that's persuasive and is based on real data, not what people say that it's going to be. So I kind of like this concept that you have the ability to go from something that looks like just a very cool thing in a 3D cave at a national lab to something that actually has real physical steel in the ground value to be developed by using real data, by using advanced modeling that allows people to see things in a real-time way, and make it so that you have this range of scenarios for the commission. So that's the commission part. On the technology and on the utility standpoint, we're doing a lot of grid flow power modeling, which is really based on the topology that would normally be used as a base case for putting out the feeder and just doing poles and wires you normally would to meet the load, versus doing it in more solar, more batteries, and different kinds of scenarios. And we're doing that in a more advanced way than is typically done, say, the distribution planning function of the utility. So I think that that is an advancement that is needed in the industry, and I think that's the advantage that the utility has in this case. So I don't know, Mike, you want to speak to what Panasonic's benefit is for it?
Actually, I guess I'll speak to a couple different benefits. Yeah, from a utility perspective, the utility doesn't want other customers to subsidize what we're doing. So really, this model is helping all of our different stakeholders and partners identify kind of the costs and benefits of all the different scenarios that we can run within those models. So the utility doesn't want to burden their other ratepayers. We, as part of the development team, if we can create a carbon neutral neighborhood with an unmatched amount of resiliency, we think that's actually going to help us attract better tenants, which is going to help us as a developer, as a customer. We actually avoided putting in a diesel generator, so we are actually helping Excel and saying we want to go before the Utilities Commission with you and actually argue that I owe you a higher rate because I avoided CapEx under this pilot. There should be some sort of a resilient rate structure to capture that. So those are just some examples of, by having this type of data and model, all of the different stakeholders are sort of working together to find new business models so that everybody benefits from what we're doing in our neighborhood.
So, Damali, I'm going to go back over to you, and I'm going to ask you a two-part question. What are some of the major challenges you're seeing in Philadelphia in terms of building an efficient, technologically advanced smart city, and how close do you think the technologies today are to helping your city and other cities achieve that view of that ideal smart city?
Yeah, so no, that's a great question. So I think one of the things that's unique, I'm an East Coast girl, so I'm from DC. I've lived in Boston, New York, Philly, DC. So I am definitely kind of that East Coast vibe. And I think one of the things that when I moved to Philadelphia that was interesting to me is Philadelphia as a city is actually huge. So it's not kind of like New York where the boroughs kind of essentially operate as their own governments. They have their own courts. Philadelphia is super spread out. So if you actually look on the map of the website, it's super spread out, and driving from one side to kind of the very, very far tip. I remember driving and being like, I'm still in Philadelphia. Whereas in other East Coast cities, DC itself as a city is small. If you look at Boston, the actual boundaries of Boston is actually small. So I think that's a challenge that Philadelphia has. One of the challenges, quite frankly, that also Philadelphia has is that is actually the poorest, largest major city in the country. And so they are really looking at, again, that the Philadelphia Energy Authority is looking at, one of their mandates is to actually create 1,000 jobs related to kind of getting the city to be more energy efficient, to be more green, to be more environmentally friendly. And so combining that and actually having that as a trackable, actionable mandate, I think is a little bit different. You don't really see that kind of, we want 1,000 jobs related to green energy or related to energy based in a city. But I think one of the other things that makes Philadelphia great is that Philly kind of has this, we're going to work through our problems. And so they were definitely one of the first cities, after the kind of Paris Agreement fell apart, to jump up and raise their hands and say, we're still going to implement this. They were actually one of the first cities to implement this kind of visualization program in terms of looking at non-municipal buildings, right? So their visualization program is outside of the municipal building, but the city itself uses that information and kind of thinking about, where do we build infrastructure? One of the things that I was actually talking with the Office of Sustainability and kind of in prepping for the conference, and one of the things they actually said was surprising was how many kind of regular average citizens would come and ask questions because they found out about Philadelphia's push this Green Works program, and would ask questions about what does this actually mean for me living in an older apartment building, or what does this actually mean if I'm thinking about transitioning to another part of the city? What are the things that I can do to actually help make my new neighborhood more energy efficient, or more kind of and more in line with kind of thinking about what does it mean to be a smart city? So that's I think the answer to your first question. And I think the second question, I was a consultant, so I'm going to give a consultant answer, which is it depends, which is very much a consultant answer. I think there's still a lot of, kind of when I think about smart cities, I think there's even still a little bit of disagreement about what that even means, right? I do kind of the conference circuit as well, which I'm sure all of you do, and I've been to a number of smart city panels, and they all kind of take on a different flavor. And I think that's actually great, because I still think that means that each city has the ability to define what it means to be smart that works for them. So Forestville, Maryland, I think if I have the city right, is actually a small city in the suburb of DC. And they actually are now kind of the first 100%. They call themselves a 100% smart city. But that actually works for them in that context of they have the ability, because they're small, because of kind of geographically where they are, to do all of the things in terms of digital, in terms of collecting data and using that data throughout kind of a municipal context that just kind of larger cities is just harder to do. And so I think the technology is there. I think there's definitely an appetite. All of those cities I've lived in have an actual appetite and are putting dollars and people and resources into making their cities better with more data. But I still think we have a little ways to go.
Matt, what about you? What does NREL identify as some of the big challenges to solve for smart cities? And then again, how close do you think the technologies today are to helping solve some of those problems?
Yeah, that's a really big question. So I'm not sure how to break that particular question down. What I would say is, at least in the area of R&D and research and development for really high penetration of renewable energy, whether that be distributed or centralized renewable energy, at least in the area of R&D, again, this is our research lab, in terms of embedded intelligence that's autonomous and allows for devices at the edge and embedded at the substation level to shift load and to be self-resilient and make decisions on its own. There's a lot of this stuff that's already kind of out there in the market. I think at least what we're seeing at the lab in this area, and we're talking about autonomous energy grids, that's what I was kind of where I'm moving in this direction. There is a pretty significant gap in the way that the distribution and the generation and transmission system is currently built and designed in terms of embedded intelligence, making decisions on its own, and that you could shift load and build a microgrid in one particular space that's concentrated and has critical infrastructure, and import and export across to another particular part of another service territory or another utility. Not talking about regulation or retail energy or law or all that stuff. That's another set of barriers. But from a technological standpoint, the algorithms and the embedded intelligence necessary to do that at scale, we're not there yet. We're there in terms of smaller scale, smaller devices. We have the ability to transfer load, and we have the ability to have buildings transfer load and be self-sufficient and be able to self-consume and be able to manage their own energy. But if we're talking about from an interconnection-wide area that allows multiple microgrids to be built to be basically improve the resilience of an entire area like that and shift load from one microgrid to another, that's going to require a different scale of autonomy within nested microgrids, that's the type of work that we're working on right now. And we're using this type of technology and a lot of other types of technologies at the lab in terms of building out the requirements, the math behind it to actually allow the grid to operate in that way. Not at where we're at now, but in another 10, 15, 20 years. So that's where I see sort of the gap.
Great, and Mike, I'd love to hear, what do you guys view as some of those top challenges that really need to be addressed before we can move into this ideal smart city?
Yeah, I think it's less of a technology challenge personally and more of a business case challenge. So really the biggest thing we focus on at the very beginning of any smart city project is getting people out of their silos, getting companies out of their silos, aligning those people in a direction or stakeholder alignment, and then really working together on new business models. So, what I was talking about from an energy perspective in Peña, having the developer and the utility and the customer all sort of work together and get out of their silos, that's key, whether it's energy or any smart city approach, from streetlights to connected vehicles to energy. It's getting out of our silos and thinking about new ways to solve the business problems.
Awesome. So Matt, we have about time for one more question so that we can open it up for Q&A. How do you see this technology evolving in the next 2, 3, 5 years? What kind of projects could it maybe support?
Yep. So right now, the process between connecting building software, which essentially makes a profile of a 10-story, 20-story commercial building, whatever it is, and then transfers that load profile into the network topology necessary to produce this type of three-dimensional graphic. And then do that in a real-time way and show the power flow and see what's realistic and feasible. That's a little bit, well, we're using a high-performance computer that's about 1.2 petaflops a second.
It's about as big as my house.
Yeah, it's really big. It takes up a whole floor of a big building. And it's a little bit manual, to tell you the truth. You're shifting load data, building load data a lot. In this case, this was I can't remember, 100 terabytes of data was to do this thing. That's a lot of data. So to go from that and then to the network topology and to rapidly iterate so that you can actually do something like, okay, if we're in Detroit, we want to do this type of project that would require this much renewable energy penetration and this much net zero capability, but we don't want to have to go every time in Detroit Edison or at SoCal Ed or Sempra, whoever we work with, and say, okay, give us the 200 terabytes of data and we'll spend 3 hours or 10 days trying to figure out the next scenario. We're trying to get it much, much faster and automated so that this becomes, if at first in the lab, we get very, very quick, we can actually do this in a sequential and fast way, and then our job as a lab is not to hold that, but then eventually that gets released out. So this becomes a very cheap, fast. At some point, this should be obsolete, and we should all be in distribution planning functions at utilities or land developers or co-ops or whomever. The average user should be able to actually do this type of work, possibly on a laptop or some smaller type of device, so that you're not physically having to go to a lab and do something complex and huge like this. So that's the goal. The goal is to get this to be out into the market, cheaper, better, faster, so we can start really constructing these things and moving forward.
And Mike, do you have anything to add? How do you see this technology evolving, or what other projects could data visualization possibly support?
I think Matt actually nailed it. I think any large development or redevelopment, it can be a very valuable tool. It's just making it a little less expensive, a little bit faster, so that the rest of the world can utilize it. All
right. So with that, we're going to open it up for audience Q&A. So there is a microphone up here if you would like to come and stand at the mic and ask the panelists your question.
Sure. Hi, thanks for the presentation. My name is Ben Pickard. I'm from National Grid Ventures. It was a really cool demo of the software. I heard T&D deferral as one possible application using DERs. And I guess one thing that I've noticed is that some of these early T&D deferral programs using DERs have come up against fundamental forecasting barriers. So you'll see BQDM and also Southern California Edison's Preferred Resource Pilot have made substantial revisions or potentially canceled their programs due to big changes in the forecast load. And it strikes me that it's possible that that's due to the fundamental vagaries of like weather and economic forecasting, or it could be the chunkiness of the infrastructure, or it could be an accuracy problem with the data. I guess I'm wondering whether your work has given any insight into that issue, whether you see like a fundamental limit to how much accuracy like this can help us. And I'd also be curious from the co-op perspective as well. Thanks.
Sure. So that is an excellent question. Oh, thank you. Nice to see a National Grid person. That's my former employer. So yeah, that's a really important question you asked. So here's where that presents a problem in this particular case. But it's also an opportunity because I think that's why this project is relevant. So the reason why this project, in my belief, and we share this belief, I think will work, is because the land developer is in direct real-time communication with the stakeholders, the utility, us on the modeling side, Panasonic, the technology company, the actual owners of the land, part of which is owned by the city of Denver, about, okay, here comes a new big developer who's going to put in, I don't know, a giant hotel, 60 new houses, whatever the retail mix is, right? And they are communicating that. And we're making sure that there's not this big disconnect between what we're trying to do on the modeling side, what the utility is trying to do with the commission to get approval for rate-based investments, potentially, not necessarily, and the pace of development of the land. Because otherwise, it's just it's a research science experiment, which is not actually what we're trying to ultimately accomplish. We want to have some applied science component of it where that tool becomes relevant to actual land developers. And it's the component of the land developer communicating to the other stakeholders up front rather than, hey, here's this 50 megawatt load. Sorry, utility, can you give us the interconnection request and we'll pay the commercial industrial rate and, we're done, right? We're not doing that in this case. So I think that's where that's what the change is.
Zach Valdez, Senate Energy Committee. I'm curious about something you touched on was social equity. And so how do you address developing and engaging in sort of social inequity from a historical and social context with groups that may not have access to this VR, this AR, that may not have the technology to engage and things like, especially in Philly or, from that other perspective, how are you reaching out to those groups and making sure that they're involved in those situations?
You guys want to take that?
So I guess I can actually talk about that because that's something that is very near and dear to my heart. So I have met, people in Philly. I met a woman who said she hasn't had heat in 20 years. I met a woman who hasn't had power in 2 years, and I can't. So the co-op is actually an electricity generation provider. So we're registered with PJM. And it's interesting, kind of on your question, I was thinking about how little interaction we actually have with PECO, right? We have almost no interaction with PECO. And so that's a kind of thinking through kind of what that means. But one of the things we're kind of looking at, and again, this is kind of, kind of the folks in Philly, we kind of sit around and when we go to lunch, these are the questions we ask ourselves of how we can fix that, is how can we create this kind of net carbon, net zero cities, renewable powered cities, microgrids when people don't have the ability to even, pay an electric bill. There's no easy answer and there's no silver bullet. And so I think that's where that kind of goes back to the idea of there's not going to be a single version of what a smart city looks like because every city is going to have to adapt it for their population, their constituency, kind of understanding what their culture. I mean, we all know that execution lives and dies by culture. And looking at it from a standpoint, so if a city like Philadelphia, that's where I actually really like and help participate and help support something like we have a Solarized Philly initiative. And part of that initiative is using Philly solar installers, and the solar installer that they use specifically goes out and uses people who either dropped out of high school or ex-cons. So again, you create that community-based application of now we have solar. Now maybe we can actually start, if we have enough solar in Philly, and actually that program is now 4 times more than it expected when it launched. So now they can go to their local utility, or they can come to us as an energy co-op because we're actually purchasing electricity and we can now buy RECs from them, right? I can create a program because I don't have an overhead, I don't have an infrastructure, I don't have a rate case. And say, I can buy RECs from you. And we've actually done that, right? We've actually had programs where we've gone out and bought RECs from, rooftop solar from Philadelphians. And so I think think it's a hard question, but I think a lot of people are coming together. I'll make one more plug that I think is actually really kind of coming together from a city and community perspective, and that's this idea of wraparound services, right? And so we're starting to see a lot of work and being asked a lot of questions. Again, we're a nonprofit, so as a co-op, we're a nonprofit around seniors in particular. So wraparound is the idea of housing, health, education, and energy. So it doesn't matter if you have heat if you can't afford your medication now. So thinking about it from a wraparound perspective.
All right, well, we are out of time, so can everybody join me in thanking our panelists with a round of applause?